Okay, in this video we're going to do the final review, problem number 14 on the worksheet. It says use summation notation, and it says see some homework from section 12.1, so I took a copy of some homework. There's 3 sections that we're going to review. First of all, how to write out some lists or some sums using the notation, summation notation, writing it out in long form. This is what it should look like when we're done on this side. And then I'm going to go backwards and use some of the look at the sum written out and try to write the summation notation. So this part over here is going to look like this when we're done, and this part over here is going to look like that. So basically, this value, this is just saying that we're going to start at 1 for the value of k, and we're just going to count by 1. So it's going to go 1, 2, 3, 4, all the way up to the value that's on top. In this case, n. So we don't know exactly what n is, so it's just going to be a sequence starting when you put 1 in there, you get 1 plus 2, so you're going to start over with 3. Now this is a sum, so instead of putting commas, we put pluses in between. So this is actually going to be a number when you're done with it, if this was a number to end on. But here we're not ending on a number, we're ending on a variable, so we're just going to write out the sum, we're not going to evaluate the sum. So this one we could actually evaluate the sum and figure out what the number is. We could write equals and get a number answer over here. This one we're not going to be able to. So we start off with k equals 1, we put it in there. We then put in k equals 2. That goes in the next value of the sum. k equals 2, that would be 4. 2 plus 2. Then we put 3 in there. 3 plus 2 is 5. Then we put 4 in there. 4 plus 2 is 6. And we go on and on and on until we get to the last one, which is n plus 2. And that's our sequence for 51. All right, on this second one here, we're starting at 0, so we're going to put 0 in there. So we go 3/2 to the 0 power. So the first number is going to be 1, because anything to the 0 power is 1. Then we're going to go to the k value of 1. So we put 1 in there, we get 3 over 2. Then we put 2 in there. And 2 in there is squaring both of these. So you raise 3 to the second power and 2 to the second power. So that's going to be 9 over 4. We're multiplying by, and the next one is cubed. So 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. And we just continue on until we put n in there. So that'd be 3 over 2 to the nth power. So this is the sequence written out on the second one. Now these are the reverse of that. What we want to do is look at the pattern, but really the last term on this tells us a lot of information. So this is going to tell us the rules they're going to be in the rules, and it's also going to tell us what number we're ending on. This is going to tell us what number we start on. Basically we're going to start either at 1 or 0. So on this first one here, we would write out a sum, and we'd write k equals, let's say we're going to start off with 1, and we're going to go to 13. So then that means the top number is 13, then it goes 1, 2, 3, so that's just k on top. 1 through 13 starts at 1, goes 2, 3, 4, and the bottom one starts at k plus 1, because that's what we have down here. We have 13 plus 1, so the bottom one's going to be 13 plus 1 at the end. This is kind of telling you what it looks like. These two values are what's changing each time in the problem. Okay, so let's look at this one. Same thing happens here. We have the sum, k equals 1 to, let's see what's changing here. It looks like the signs are changing, so that's going to be -1 to the sum power. So let's figure out what this power is here. So it's going to be, so if we want it to be positive on the first one, that's 1. That's not going to be just k. It's got to be k plus 1 here. In order for this to be a 2, in order for it to end up on a positive note. Now, wait a minute, that's not going to work because our first number, this one's actually going to be not starting at 1. The reason that doesn't start at 1 because of this term right here. This term right here, it doesn't have a fraction of, so we're going to write this as 1 over 3 to the k power because of this thing. So we're going to have something here, and we're going to have, this is going to be the k value, and this is going to be the k value. That's 6. So we have to have k here and k there. The problem is the first number is 1. So in order to get 1, k has to be 0 here in order for this to change to 1. Because anything that's 0 power is 1. So that's how we get this first number to be 1. We start out with 0 and we go to 6 because 6 is the last number we see here. Alright? So this one we had to start at 0 because of the first term not being negative 1/3. The first term is 1. Alright. Alright, let's do 67 too just for practice. Alright, this is, it looks like this is their formula. It looks like 3 to the k power over k. We have to change the variables because the sum is going to start off with this number right here, and that's going to be the top number, n. And we're going to figure out whether k starts at 0 or does it start at 1. So if I put 1 in here, that's 1, 3 to the first is 3 over 1, which is 3. That looks like the first number in there, so we'll start at 1 instead of, we have to make sure we get this first number when we stick in this number to the problem. If not, we have to try a different number that'll give us this answer. Then this seems to work. So this is our answer for 67. All right. Okay, so here's the second part. The second part is evaluating some formulas, just writing them out and evaluating. Now if we have a short sum, if I was just doing this one where I had the sum of k equals 1 to 5 of 8, then I wouldn't have to use a formula. I would just say there's basically 8 plus 8 plus 8 plus 8 plus 8 1, 2, 3, 4, 5 times because we went from 1. Here's k is 1, k is 2, k is 3, k is 4, k is 5. So we have 5 eighths, which is going to be 40 in this problem. Now if we have big numbers on the top though, we have to use a formula, and in the book they had formulas for each one. For a constant, we just multiply by this n times this constant. Now you can write these on your page of notes. I don't think I'm going to go any further than these two here, but maybe you should write the k squared. I'm definitely not going to put a k cubed on your k to the third power on your problem set, on your test. So if you have these three written down on your thing and know how to use them, then that's going to be good. So let's do 76. We'll do 76 and 77 because those are the ones that use the multiple formulas. So in 76 here, we have two parts here. We have a constant, or a k value, which is this one right here, and we have a constant right here, which is this one right here. So we're going to actually use two different formulas for 76. We're going to take, and we're going to break this up into two different sums. So we're going to have the sum of 3k, 3 times k, minus the sum of 7. Alright, so using the formulas, 3k is 3 times this value. So we're going to have 3 times n times n plus 1 over 2. That's going to be our 3k, and then we're going to have minus c, which is 7 times n. So this is c, so it's 7n for the second part. So we're going to have this, and we just have to figure out what n is. N happens to be this number right here. This is n. So we're just going to plug in 26n equals 26 in this formula, and we're just going to evaluate that. So if we do that, I'm going to write it down here now. So I have 3 times 26 plus times 27, it's n plus 1, divided by 2 minus 7 times 26. And we're just going to evaluate that on the calculator to figure out what that is. So we have 3 times 26 times 27 divided by 2. That's going to be 1053 minus 7 times 26, which is 182. And we're going to get minus 1053. We're going to get 871. I subtracted them in the wrong order on the calculator, so it gave me negative 871, but it's 871. So we're just using this formula and this formula. This formula gets multiplied by 3 because it's 3k. And this formula is a 7 for C, so it's 7 times 26, or 7n. All right, so I think that if you knew this problem right here, you should be okay on the test. If not, you're going to use this formula. If it's a k-squared like this one, you're going to use this formula, and in this one it goes to 16, so 16 goes in for all the n's here. Figure it out. And then plus this formula right here, where C is 4 times 16 right there for that part. And then you're going to add them together. So that is basically your review for problem 14 for the final exam.